and hit those. So does this attain a maximum and minimum value on the interval 0 less than or equal to x less than 1? All right. Couple ways we could think about this. We know what this graph looks like, don't we? What's 2x? Just a line. If we looked at that graph, you put in 0, you get 0. If you put in 1, what do you get? But because it doesn't have an equal to, it would have to be an open circle. So we're just taking a portion of a line. Does this one have an absolute max? No. Why? Because of that open circle. So remember, what we were working on Friday said we have an absolute max and min, assuming that the interval was closed. If you have an open circle, then that changes everything. Do we have an absolute min here? Yes. It would have been at the point 0, 0, or you could say f of 0 equals 0, depending on how you write that. So if we had done the derivative of this, which is the other option we talked about, doing the derivative and finding your critical points, the derivative is just 2. Does 2 ever equal 0? Is it ever undefined? No. So there is no critical point on this one. That means the only place you could have a max or min is at the endpoints, like we see from the graph. So you do have to watch there if you have an open interval. All right, so I wanted to kind of go back and hit some of the weird scenarios. So this is one of them, when we had an open interval. The next one I wanted to look at was a piecewise function. So remember, we had our critical numbers were places that we could have a max or a min. And we said that worked if you had a continuous closed interval. So the last example we did, it wasn't closed. This one is a case where it's not continuous. So let's look at what happens there. Thank you. Let's look at the graph. It might be easiest to do this one from the graph. 1 if x equals 0. What's that? Just a dot on the graph. When x is equals 0, we get out 1. 1 over x for 0 less than x less than or equal to 1. We can't plug in 0 anyway. If we put in a 1, 1 over 1 is 1. If we put in 1/2, what's 1 divided by 1/2? 2. If you put in 1/3, what's 1 over 1/3? 3. So this one just has a vertical asymptote at 0. So it looks like this. So we have 2 endpoints, but it's not continuous because we have a break in our graph. Do we have an absolute min in this one? Yes, we have 2 of them. F of 0 equals 1 and f of 1 equals 1. So 2 absolute mins, but do we have an absolute max? No. Because of that vertical asymptote. So we have to watch. If it's not continuous, we have to look at what's happening to our function. Let's see, we did example 6 Friday. Let's look at example 7. How do we find critical numbers? Derivative is 0 or undefined. Okay, where the derivative is 0 or undefined. So this one, what rule would we have to use to do the derivative? Quotient rule. So low d high, derivative of the top would be 6p minus high. D low, derivative of the bottom. Over low squared. So this would give me a 6p to the third minus 24p minus 6p to the third. So critical points. When does this derivative equal 0? When the bottom is 0, that's when it's undefined. When it's equal to 0, it's really when the top is 0. So if you have a fraction, you're really just doing what makes top and bottom 0. Those would be all your critical points. If you set this equal to 0, you would have negative 24p equals 0, so we get p equals 0. We also have to look at undefined, so when does p squared minus 4 equal 0? And that would give us plus and minus 2. So this one had 3 critical numbers. We can't find the max and min because I didn't give you an interval here. I was just wanting those places where you could have maxes and mins. Is this one okay? So if I want the max and min, we haven't done an absolute value in a long time. Remember, absolute values, we had an issue with them when we looked at the graph. The derivative didn't exist at a sharp corner. So before we ever did the derivative, we always had to rewrite this without absolute value symbols. When we do that, it'll turn into a piecewise function. Your breaking point is when the inside of the absolute value is 0. So what makes that 0? 2. So we'll have one case if x is greater than 2, one case if x is less than 2. If x equals 2, we already know that's a corner, so the derivative doesn't exist there. So we already know one critical point, which would be 2, because that will be the corner of the absolute value, and we know the derivative does not exist. So that is my first critical point. If x is greater than 2, then that absolute value is positive, so it's not doing anything. So you could just drop it. So then it turns into a 3 minus x plus 2, or my total function would be 5 minus x. If I put in something smaller than 2, then the absolute value would do the opposite of it, so it would become a plus here. So we would get a 1 plus x. Do you guys understand how I rewrote my function without our absolute value? We've done that, but it's been a while since we've had to. So if we're looking at the derivative, we just do the derivative of each piece. What's the derivative of 5 minus x? Negative 1. What's the derivative of 1 plus x? Positive 1. Okay. Does this derivative ever equal 0? No. 1 doesn't equal 0, negative 1 doesn't equal 0. So my only critical point is x equals 2. because critical points are where the derivative is 0 or undefined. It's never 0, but the derivative is undefined at 2 because on the graph we would have that corner there. That's the breaking point when we jump from one piece to the next. All right, so the max and min. Remember from Friday we have to test the endpoints and any critical points that fall in the interval. So we need to look at 1, 2, and 4. And we are putting these back into the original equation. So if you put in a 1, 3 minus the absolute value of 1 minus 2. So the absolute value of 1 minus 2 will be 1. 3 minus 1 is 2. Okay, if you put in a 2, 3 minus the absolute value of 2 minus 2. So 3 minus 0 is 3. If we put in a 4, 3 minus the absolute value of 4 minus 2. So 4 minus 2 is 2, 3 minus 2 is 1. So this is my absolute max because it's the highest y value. This is the absolute min because it is the lowest y value. Yes?
For this part, where do we get negative 1 more?
So derivative of 5 is 0 minus
Yeah.
derivative of x is 1.
Thank
You're welcome. Other questions? So in order to find max and min, we have to do derivative. Right, so if we set, we can just jump right into our derivative here. We don't have to do anything weird. Okay, so exponent comes down. So that's going to be 5 times 2 over 3, which would be 10 over 3. X, if you subtract 1 from the power, so it's like 2 over 3 minus 3 over 3, which would be negative 1/3. Minus, exponent comes down. X, if you subtract 1, that's like a minus 3 over 3, so that would be 2/3. So now what do we do with this? Equal to 0 every time. So now for solving this, there's different options. We did one Friday where I had you like add the term over and cross multiply. You could do it like that. If you just want to think about factoring, that is also an option. So if we're looking at the numbers, 10/3 and 5/3, you could take out a 5/3. If you are factoring, you always take out the smallest exponent, which would be negative 1/3. All right, let's practice our skills here. 10/3 divided by 5/3 would give me what? 2. You took out all those x's. Minus, I took out that 5/3. If you take out an exponent, it's like subtracting. So this is like 2/3 minus negative 1/3. So what would that turn into? 1, just an x to the first. Okay, it might be helpful to think a negative 1/3, remember a negative puts it on the bottom, so it's like a cube root of x on the bottom. Critical points are anywhere this derivative is 0 or undefined. What makes it undefined? When the bottom is 0. So when x is 0, the derivative is undefined. What makes this derivative equal 0? 2. So those are my critical points. Are both of those in my interval? Yes. So we have to test the endpoints and both critical points. We are putting these back into the original. Alright, let's kind of divvy up the work here. Why don't you guys do -1, 0, you guys do 2, you do 4, why don't you check -1 as well. What did -1 give you? Okay, what about 0? 2? Probably not nice. Give me a couple decimal places.
1.7622.
Is that what you guys want to use? 4?
2.5198.
2.52. So our max is and our min is everybody understanding how I'm getting my critical points and finding our max and min here? Let's try one more, but you guys have to tell me what to do here. Find the derivative, first step. What is the derivative? We need to figure out when this is 0 or undefined. First of all, can you just look at that and tell me, is it ever going to be undefined? No, it's a polynomial. Things that make it undefined would be negative exponents or fractions. Okay, so if you don't have any negatives or fractions or absolute values, I guess I should say that, then we don't have to worry about that piece. So we just need to know when it's equal to 0. Can I divide all those by anything? No. So what do? You can, let's see if it factors nicely first. So we need two things that multiply to a -60 and add to a -28. That would be a -30 and a +2. So factor, we could take out 6x and a 1. Here we could take out a 2x minus 5. So if we set those equal to 0, get a -1/6 and a +5/2. Okay, so those are my critical points. Are both of those in my interval? No, 5/2 is 2.5. It's outside my interval, so I don't have to test that one. So we need to look at -2, -1/6, and +2. Oh. I may have put it in wrong. Make sure you put the -1/6 in parentheses. That's what I had. -2.57 actually is what I had. I got -2.57 again. Make sure if you're putting in negatives or fractions, put them in as like in parentheses. Two, what did you get? Okay, so we see -81 is our absolute min at -2.57. I put down 6. Should be our R max. Okay, we'll grade yesterday's homework and then I have a handout for today.